For this lesson, you may want to wear some shades as we discuss the true color of the sun. No doubt you've noticed how during a sunset or sunrise, the sun has an orange-red hue, while at high noon the sun is basically white. The sun doesn't actually change color. It is the position of the sun relative to where you are that results in all those cool and pretty apparent changes in the color of our sun. This lesson will outline for you why the sun is one color at high noon and totally something else at sunset. Although the sun is sometimes referred to as a yellow dwarf star, the name itself is a bit misleading, since the true color of our sun is white. Don't believe me? No problem. Take out a sheet of white paper, then shine a red laser onto it. What color will the paper appear now? Red. It appears red because you can clearly tell that the type of color illuminating the white paper represents the color of the source of its illumination. A white piece of paper turned red because a light source of a red color illuminated it. Now, take that paper outside at high noon and tell me what color it is. It's white, the color of its source of illumination, the sun. This means that the sun emits a color of light, white, that represents a rainbow of colors mixed together. Don't believe me? No problem. If you have a prism, you can split sunlight into its constituent rainbow of colors to see what I mean. A prism is a transparent object that can disperse light into a spectrum. A spectrum is an arrangement of colors, as if in a rainbow. All of these colors of light have different wavelengths. A wavelength is the distance between two corresponding points of a wave. The image on your screen shows two corresponding points on two different waves. One of them has a shorter wavelength and the other has a longer wavelength. Some wavelengths of light are shorter than others. Blue has a wavelength that's shorter than green, which is in turn shorter than red. You are now fully ready to understand the changing color of our sun at sunset or sunrise. Earth has a filter called the atmosphere that's composed mainly of molecules of nitrogen and oxygen. Like any filter, such as a water filter, some stuff will make it through and some stuff will not. Longer wavelengths of light, namely red, can penetrate the atmosphere much farther than shorter wavelengths of light, such as blue. When the sun is directly overhead, it doesn't have to penetrate through the Earth's atmosphere very far. When the sun is setting or rising, it's on the horizon. Since it's on the horizon, it has to have its light rays penetrate through a much thicker amount of air. Because of this, only the longer wavelengths of light, like orange and red, reach our eyes. The shorter wavelengths of light, like blue and green, are scattered away by the air before they reach our eyes. As a result, the sun and some of the sky around it appears to be filled with lots of orange and red colors. The sun is sometimes referred to as a yellow dwarf star, although it's really white. White light is a mixture of colors. You can see for yourself if you split the sunlight into its constituent colors using a prism. A prism is a transparent object that can disperse light into a spectrum. All of these colors of light you see split by the prism have different wavelengths. A wavelength is the distance between two corresponding points of a wave. Longer wavelengths of light, like yellow, orange, and red, are less easily scattered by our Earth's atmosphere. When the sun is setting or rising, its light has to go through a thicker layer of air. This means shorter wavelengths of light will be scattered away and only longer wavelengths of light will reach our eyes. This results in a yellow, orange, and red sunset.